All right, folks, in this section, what we're talking about is rotating area around either the x-axis or the y-axis, and then getting a three-dimensional shape, which we'll want to find the volume for it. So if we start here, you'll notice that when I'm wrapping around the x-axis, I'm going to take the y equals, and I'm going to make it squared. So here's my function f of x, and it's the square root of x plus 1, but I'm going to rewrite it as x plus 1 to the 1/2. And then keep in mind that what I've got to do is I've got to square this. So remember, when you're squaring, raising a power to a power, all you're doing is multiplying the exponents. So this is going to end up being x plus 1 to the first power. Now, I could do this with a first power, or I can do it just like x plus 1, because at the first power, it's still going to be x plus 1. So let's take a look at that. If I integrate that, I'm going to have raise the power by 1 and multiply by the reciprocal. I end up with this. Now keep in mind, I've got to make sure that I multiply pi times whatever I get for an answer. But see, once I've got it set up to this point, it's very much like doing area. So all I do is input the 3 and then subtract whatever I get when I put in the 0. Anyway, I've got a 7.5 minus 0, or 7.5 pi units cubed. Now for this next one, I've got f of x is equal to 3x to the 1/4. Now remember, it's already set to y equals, so I'm going to use this rule. But remember, I've got to square it. So in this case, I've got to square both the 3 and I've got to square x to the 1/4. So that's going to end up looking like this. And so now all I've got to do is integrate this. And if I add 1 to the power, multiply by the reciprocal, I should end up with this, but I'll clean it up some more. And I'll end up with 6x to the 3/2 power. Now, my boundaries are 4 and 1. And so all I've got to do is put a 4 in there, and I'll get a 48, and then minus the 6, I get 42 pi. So in the next one, we're finding the volume of the area between the curve and the x-axis. Oh, I'm sorry, the y-axis, and they rotated around y equals 2 and y equals 5. So basically, let's do a quick sketch here. I've got a parabola. It's at x squared, so it's a pretty easy one to draw. And I've got 2 and 5. Whoops, not 2 and 5. I want to make this y equals 2 and y equals 5. Because remember, I'm going to wrap this around the y-axis. And basically what I'm looking at is this shaded area here. I'm going to wrap it on the y-axis, and so I'm going to create this three-dimensional shape like a bowl. So I've got my boundaries, 2 and 5, and I've got my function, only it's set up as a y equals. So what I've got to do now is I've got to rewrite this so it's x equals. Well, all I got to do is solve for x, and so it's going to be the square root of y is going to equal x, and so now I have to square that. Well, squaring a square root just gives me the original, so I'm going to end up with y, and now I've got to find the derivative of this. And all I got to do is raise the power by 1 and multiply by the reciprocal. And then my boundaries are 5 and 2. So if I put those in there, substitute them in, I'm going to find out that I get 12.5 minus 2, or 10.5 pi. Now in this next one, I've got a shaded region, and it's rotated around 360 degrees around the y-axis. And they want us to find the volume. And I've got a couple problems here. First, you'll notice that I don't know my upper boundary. I don't know what this y equals line is. I have the lower boundary, y equals 1. And so the first step of the problem is going to be to establish what that is. Well, luckily it's a y-axis and it's a y-intercept. All I've got to do is make my x equal to 0, and that'll be the y-intercept. Well, when I do that, I find out that y is equal to 2. So that now I've got my boundary. And so now the next thing I've got to do is I've got to rewrite this function so it's equal to x, not equal to y, because I'm wrapping it around the x-axis, or I'm sorry, the y-axis. So let's go ahead and try doing that. Let's rewrite it so it's going to be x equals, not y equals. Solve for x. So y equals 2 over square root of x plus 1. Well, if I multiply both sides by square root of x plus 1, I get 2. And then if I divide by y, the square root of x plus 1 will be by itself. And then if I square both sides, I'll get x plus 1 is equal to 4 over y squared. And all I got to do is subtract 1 from that. And see, now I got x by itself. Now that's the thing that I'm actually going to take and integrate. And then once I integrate it, I'm going to take the boundaries and multiply it by pi. So let's go ahead and find the volume. Now I'm going to rewrite this so the y squared is up in the numerator, so I've got to make that power a negative. But then I've got to square it before I take the derivative. So remember, you're squaring it before you take the derivative. Well, just squaring a binomial isn't as big of a deal. You square the first term, multiply the two terms together and double it, and then square the last term. And now I'm going to find the integral of this, which again, you raise the power, multiply by the reciprocal, raise the power, multiply by the reciprocal. And I'm going to get this as my integral function. And see, now all I got to do is establish my boundaries, which are 2 and 1. And substitute those in and subtract them, and I'll find out that the volume is 5/3 pi units cubed. Now, sequences in series. Keep in mind you're going to have these formulas. You just need to know how they work. And in this first one, we're talking about an arithmetic sequence. Keep in mind an arithmetic sequence is when we add a number each time. And they give us the first term, they tell us it's 12, and they tell us the seventh term, they tell us it's 36, and then they tell us the last term is 144. So what I've got to do is figure out what the D is. What did I add each time? So when it's set up like this, it's not too bad, because you know that what's going to happen is I'm going to add D to 12, and then whatever number I get, I'm going to add D to that, and then add D to that, and add D to that, and add D to that. And when I do all those, added those D's, I'm going to get 36. So now all I've got to do is rewrite this as an equation, and that's going to be 12 plus 6 D's is equal to 36. And see, now all I got to do is solve for D, and I find out that my D is equal to 4. Now that I know that, I can look at the formula and see which one I want to use to find out how many terms are in the sequence. Well, I'm going to take this one over here because I know what the last is. And so if I fill in the last, 144, and the first, and I don't know n, but now all I got to do is solve for n. And when you do, you'll find out that n is equal to 34. Now in this next one, they give us information. They tell us basically that there are 20 terms, and they tell us that the first term, or A, is -5, and the last term is 90, and they want us to sum all those up. So I'm probably going to use this formula right here. So the sum is going to equal 1/2 n times A plus the last. And see, now all I do is fill in the information that I know, and then find out what it equals. 10 times 85, 850. Now in this problem, they give us a formula, and they don't give us the terms in the sequence. We know it's arithmetic, so we've got to figure out what some terms are, at least the first one, and I got to figure out what D is. And so if I go ahead and try this, the first term, well, the first term is going to be 14 plus 2 times 1. Well, 2 times 1 is 2, 14, that's going to be a 16. And the second term is going to be 14 plus 2 times 2. Well, that's going to be 18. And the third term is going to be 20. And see, I know that D is equal to 2 and A is equal to 16. And so now all I got to do is find the sum using the formula above. I don't know the last, but I can use this formula here because I don't need to know the last with it. And all I do is fill in the information I know. I know N, I know the first term, I know D. All I got to do is find what it sums to. And then I find out it's going to be 324. Now, in this next one, it says how many terms are there in the arithmetic progression? Well, let's get that a little higher. Thank you. So the first term is going to be 120. The last term is going to be 36. And we can figure out pretty quickly that D is -6. So all I do is take the formula that has this information in it and fill in what I know. I know that the last term is 36. I know the first term is going to be 120. I don't know how many terms there are. I know that D is -6. And see, now all I got to do is finish it by finding out, get N by itself. Now, in this next one, I apologize. It's screwed up. It shouldn't say the 11th term. Should say the first term. The first term in the arithmetic progression is 6, and the fifth one is 12. And if we kind of lay this out, we got the first term, and we know that's going to be 6. And then we make some more spaces, and we get the fifth term, and we know that's going to be 12. And see, then our problem again is we got to figure out what D is. And so like the last time when we had that problem, all I got to do is keep in mind that I'm going to add D to 6, and then whatever that is, I'm going to add D to that, and whatever that is, I add D to that, and then again to get the last number. So when I write my equation, it's going to be 6 plus 4D is equal to 12. Well, now all I got to do is get the D by itself, and I figure out that D is equal to 1.5. Well, now I know the D, I already know A. I realize they've also given me the sum, so I'm looking for a sum formula, and I use the one that has the information I have, and I fill in all the things I know. The only thing I don't know is N. So really, this is just about multiplying and distributing. And once I do that, I will get an interesting quadratic. And you just got to be careful when you're doing your multiplying. In this case, you get 21 over 4n plus 3/4 n squared. Well, I'm going to get rid of that by multiplying everything times 4 and make that a much more user-friendly quadratic. Now all I got to do is divide everything by 3 and then factor this. And I'll find out that n is going to be either -15 or 8. Well, it can't be -15. That's not possible, so it's got to be 8. Okay, so in these next problems, what we've got is geometric sequences. And so we've got a first term and a common ratio. The common ratio is the number we multiply each term by to get the next term, and then a number of terms. And you see the formulas up here. Again, they'll be provided for you. You have to be familiar with how to use them, though. There's a couple sum formulas, and then there's the one basic one. So in this case, they want us to find the last term. That would be the 8th term. And so I'm going to use this formula up here. And so let's try it. If I write the formula first and then fill in the information that I know, all I got to do now is take 2 to the 7th power and multiply by 3. And I find out that the 8th term is 384. That's the last term. Now to find the sum, I use the formula and fill in the information that I know. And all I've got to do is sub it in and then simplify. And I find out the sum is 765. Now for this next one, I've got the first 3 terms, and I want to calculate the sum to infinity. Now keep in mind, in order for me to do the sum to infinity, r has to be between -1 and +1. And I can, because in this case, I can figure out pretty quickly that if I've got going from 4 to 2, I must be multiplying by 1/2, and then I double check it. 2 times 1/2 is also 1. So I know that my r is going to be 1/2. So now all I do is plug it in the formula. It's a pretty easy formula, a over 1 minus r. And so all I got to do is fill that in, and I get 4 over 1/2, which is equal to 8. In this next one, it's pretty similar. I've got a first term and a fourth term, and they tell me that the first term is 81 and the fourth term is 24, and I've got to figure out the r. And so I'm going to do kind of like what I did with the arithmetic ones. I know that the 81 got multiplied by r, and then that answer by r, and that answer by r. And so what I'm going to do is rewrite that as an equation, and I get 81 times r to the third, because remember, it's not 3 times r, it's r times r times r, and that's going to equal 24. Well, so now all I do is divide both sides by 81, and then simplify it, and I'm going to find out that it's 8 over 27, and take the cube root of that, it'll be 2/3. That's my r. And see, once I've got the r and I've got a first term, finding the sum to infinity is pretty easy.